I'm a scientist. I'm going to talk about some of the aspects of my career up to this point. And my talk is called The Twists and Turns of a Career in Climate Change, because that's what I work on now. But I didn't always work on climate change, and I want to tell you a little bit about how I got there. In fact, I didn't always want to be a scientist at all. When I was very young, I wanted to be an air hostess. Then I wanted to be a nurse. Then for some inexplicable reason I wanted to be a dairy farmer, until I realised you had to get up really, really early in the morning, so that was out because I'm not much of a morning person. And then because I loved animals, I thought, well, a job as a wildlife photographer would be rather glamorous, but then I realised that it was going to be very difficult to get a job. Then I had a sort of a light bulb moment, I suppose. I read this book by a man called Konrad Lorenz called King Solomon's Ring, and Konrad Lorenz really invented the study of animal behaviour, and I was fascinated by animals. I had my bedroom when I was growing up was full of jars of lizards and cockroaches and snails and all sorts of things. And by reading this book, I realised that somebody could actually have a career studying animal behaviour. And I thought, well, that sounds like me. That's what I want to do. So that set me on my path to university. I decided I'd do a science degree because that's the best way of studying zoology. I always thought, so I went to Sydney University, which is in that picture, and did a Bachelor of Science and an honours degree. I always thought I'd work on some sort of mammal or reptile or amphibian, a kangaroo or frogs or something like that, because they're the things that I really aspired to work on. But actually, that's not what happened. I ended up working on insects. I discovered insects, I discovered how fascinating they were, and I discovered how important they were. In fact, about 97% of all biodiversity is an invertebrate of some sort, and I decided that really insects and bugs and things were easier to do experiments on than the larger animals. So that set me on one sort of a path. After my degree, I decided I really needed to earn some money, so I sort of went off the rails for a little while in terms of my scientific career, and got a job in an office for a year to save up to go travelling. And while it was a very boring year in some ways, sometimes the most boring jobs that you don't really want can also be really important, because they do teach you about what you like and what you don't like. And the one thing I learnt from working in an office for a year was that I never wanted to work in a big open plan office for an insurance company ever again. So that made me doubly determined to try to pursue a career in science. So sometimes the most unlikely activities and unlikely jobs can really help you decide what you really want. And I think that worked for me. So after my year in the insurance office, I had a year that was much more fun, travelling all over the world, all over Europe and the Middle East and India and places like that. And I still have a love for travel and try to do it in between my day job as often as I can. But reality set in, ran out of money, had to come home, came back to Sydney University and started doing some teaching. And then after 3 years, I decided I really needed some more qualifications, because by that point I'd decided that I really wanted to be an academic. I wanted to do research, I wanted to teach in a university as a career, and it's still the case, and it was then, that in order to do that, to be qualified enough to do that, I had to go and get another degree, which was a PhD. So I wanted to change from Sydney University, so I came here to Macquarie University to do a PhD, which is basically a 3 or 4 year period of doing research on a particular topic. And this was my topic. I studied the way ants, which are very important little creatures, even though most people are just annoyed by them, carry seeds around the bush. If you look at that picture there, that's a seed of an acacia, a wattle, and you'll see that it's got a big yellow thing on the side of it. That's an ant attractant. Ants love those. They're really fatty and delicious, full of calories. Ants pick up the seeds, they take them back to their nest, they nibble off that little yellow thing, and so they disperse the seeds away from the parent plant. And it's a mechanism that lots and lots of plants in Australia have evolved to get their seeds dispersed around, and ant behaviour is very important in that setting. So I studied that for about 4 years, but after about 4 years I got my PhD, but I decided that it was really time for a change. I didn't want to spend the rest of my life following ants around the bush. You're probably not really surprised about that. So I cast around for something else to do. And this is what I became interested in. This was back in the early 1990s. Climate change wasn't really the sort of hot political topic that it is today, but it was an area of scientific interest, and the more I read about it at the time, the more important I realised it would be, at least for the future. So I decided to switch gears a bit and do some experiments on climate change impacts. And of course I've been in that field ever since. And this is the reason why I've stayed in that field. Global temperatures, I know you all know this because you probably do quite a lot on climate change science at school. They're going up. They've been going up very strongly ever since the Industrial Revolution, when we started burning lots of coal and putting it into the atmosphere and putting in lots of more greenhouse gases which trap the heat around the Earth and make it warmer. So that's what's been happening, and I decided I wanted to look at the impact of that on some of Australia's native species. So to cut a long story short, I did a big experiment. I did lots of driving up in outback North and Central Queensland, taking plants from one type of environment and putting them into a different type of environment to try to see what might happen to those plants in the future as the climate changed. It was a lot of work, but I learnt a lot about the Australian outback and about being self-reliant and all of those sorts of important things. During the course of my research, I've done all sorts of other things. For example, from time to time, little side trips. This is me abseiling down a cliff very inexpertly. I'm not much of a rock climber, but I was very fortunate to go and be able to see the Wollemi pine in its natural setting. The Wollemi pine's a living fossil. It's been here for about 65 million years, and until a few years ago nobody had ever seen one before, and it's still the case that not many people have seen them in the wild, and I feel very privileged to have done that. So I did some research on why that Wollemi pine is still there, how fire has affected it and how fire has protected it. So that's just one little side project that sometimes scientists are privileged to be able to do. Anyway, after doing my PhD and doing some research on climate change at Macquarie, I decided, my husband and I decided that we'd go to the US to do some research for a while, and we were also very fortunate to end up at one of the most prestigious universities in the world, Harvard in Boston, and we lived in Boston for 2.5 years. And I did research there on those little aphids that you see at the bottom of your screen. I also had 2 children there. They're American citizens. They were born there. So it was a pretty busy time fitting in research and teaching and having 2 babies, but it was also a lot of fun. Came back to Australia then and was very fortunate to be able to come back to Macquarie and get a job here as a lecturer, and basically I've been here as an academic ever since, and I continued on looking at the impacts of climate change on insects, particularly butterflies and beetles and all sorts of things like that. And so this graph really sums up why I'm still in this game, really. This is our potential future. That little black wiggly line at the bottom of that graph shows the temperature that we've had on the planet so far since the beginning of the last century. That blue area there is the temperature we might expect to get for the rest of this century if we really drastically cut our emissions of greenhouse gases, and unfortunately we're not cutting them nearly enough. So a more likely future at this stage is that red area on the graph, which shows potentially average temperatures going up to about 7 degrees above what they were in pre-industrial times, and the average of that area is about 4 degrees. And most climate scientists, who are a lot more expert at climate science than I am, think that a 4-degree future for the rest of this century is very likely. Now, of course, a 4-degree future is actually a pretty scary prospect. because it has all sorts of implications for things like bushfires and heat waves and cyclones and sea level rise, and every single species on Earth and every single human on Earth will be affected by that. And it's such an important issue that, as I said before, once I got into it, I really couldn't let it go. But a career in climate change has had all sorts of benefits, because it's opened up because it is such a global issue and such an important issue. It's given me lots and lots of opportunities that I have really relished, to travel. As I said, I love travelling, to be part of international organisations. The IPCC is one of them. It's an international Intergovernmental Panel on Climate Change. This organisation actually won the Nobel Peace Prize in 2007, and I have a certificate to show that I was part of the organisation at the time, which was a real thrill. But the IPCC is a group that puts out reports every 7 years on the state of play in climate change, and I'm one of many, many thousands of authors that contribute to that. So my role is very tiny. I'm a grain of sand on the beach, but nonetheless it's been enormously satisfying to feel that I've been part of that international effort. One of the other things I've been very privileged to do is to be a member of the former Climate Commission. The Climate Commission was set up by the Gillard Labor government in 2011. Tim Flannery there, you're probably familiar with, was our chief commissioner. I was one of the 6 commissioners. We travelled all over Australia for about 2.5 years, talking to people about climate change, visiting companies. I've got to meet the Prime Minister, all sorts of things, trying to bring good information, credible information about climate science to people in the public who were interested in it. It was enormously fun. I learnt a lot, and met probably thousands and thousands of people all over the country in that 2 years. The commission was abolished by our current government, so we decided to keep going and started up something else, the Climate Council. Some of you might be familiar with this, and we now raise money from the public to keep going with our communication message. We're nearly 1 year old. We raised about over 200,000 in the first 24 hours and over $1 million in the first week, and we're continuing to raise money. And if you are interested in any of the Climate Council's activities, our Facebook page, our Twitter feed, all the reports and things that we put out, then there's a website there that you can go to, and we'd love for you to join us and be part of our activities. Okay, so that's just a few of the sort of things that I've done along my twisted path. Who knows what's next? I'm still very actively pursuing both climate change research and climate change communication, and enjoying it a great deal. This arrow up on the top of the screen is about where you guys are, I suppose, in thinking about your careers, and you can see that I've done a lot of things and been a lot of places since that time by having a career in science and kind of following my nose and grabbing opportunities when they arrived. So let me sum up with a few things about what I think of as a career in science. Science is about finding out new things, and there's nothing much more exciting than that. It's about applying this knowledge to real-world problems to try and fix problems. It's about being creative and productive. You don't have to be an artist to be creative. Science is a very creative enterprise, and I don't mean we make up data, but we do have to be creative about how we find things out. And as more of a philosophical point, it's a fantastic way of leaving something behind you when you're gone. I think most scientists have a craving for some sort of immortality, and leaving behind the results of their research is one way of doing that. And I think that's a pretty exciting thing to do as well. And it's fun, and it can be pretty surprising, as I hope some of the things I've told you this morning show. And more specifically, I want to just very briefly end up with some things about a career in climate change, because it's such an important issue. In my view, it's the most important issue facing the world and facing all of your lives into the future. And we need people in that career, doing careers. We need to find out what the future will be like. We need to find out what the impacts of climate change will be on all sorts of things, our environment, our cities, our communities. We need to find out how to adapt to the inevitable climate change impacts as they hit us. And most of all, we need to find out how to fix the problem. We need engineers with new renewable energy technology, all sorts of things like that. And we need to find out how to live differently, because the way we've been living on this planet is killing it, and we can't afford to keep doing that. Thank you very much.